Well, welcome to the Live Electric Now podcast. This is the fourth episode of a four-part series where we're talking all things electric vehicles. And we've been leading up to this week, which is National Drive Electric Week. So happy National Drive Electric Week. I'm your host, James Campbell, and I'm joined with Chris behind the glass and Joe. Gentlemen, how's it going?
Fantastic. Thank you for asking.
Joe, how's your boat? Is your boat still working? Barely, yeah. Well, you gotta scrub the muscles off on there. But no, this is we're really excited to be here. We're coming live from the Project Open, which is here at the Give Group. And again, thank you so much to the Give Group for hosting us. And Project Open is really such a fascinating project where it's an all-electric building where the residents can live here completely emissions-free. They're served by 100% renewable energy. It's such a fantastic concept, and we really appreciate the hosts for hosting us. Well, as I said, this is the fourth part. This is really the discussion around what's next in electric vehicles, and to really help with this conversation, we have really just a fantastic guest, someone who is really so knowledgeable in this. He is the David G. and Diane L. Sant Endowed Professor at Utah State University, and he's also the director of the newly created $50 million NSF-funded Aspire Center. Professor Regan Zane, welcome.
James, thank you.
Yeah, so I just love that name, Regan Zane, and you hear me say it all the time, but I just love it. It's such a strong stage name. Is there a story behind it? Is it just a family name, or?
Well, I have to thank my parents for that. I believe at the time, my father, he was a fan of Ronald Reagan, thought he was a great actor, upcoming politician in California. He called him Regan, and I believe that when I was born, they thought it was a good role model. And my mother spelled it the way he says it.
Okay, well, I guess that makes sense then. Tell us about. So you grew up in Idaho, just up north at the. Really grew up at the Idaho National Laboratory. Your dad was the administrator of that facility, the grand poobah, the person in charge and running it. So what was that like growing up at a nuclear facility and research facility?
It was fun. I grew up in Idaho Falls. Great childhood. Enjoyed the area. Wasn't that far from here. My father was the general manager of EG&G at the time, and so they ran Idaho National Engineering Laboratory, or INEL at the time. A lot of exciting things. Things I remember. Probably the one that drove me crazy the most was that my father would occasionally, I forget if it was annually or every other year, but occasionally he'd spend the night away, and this would be when they were doing the war games up at INEL. And so he and his colleagues, they get to sit up on the top of the building and watch the SWAT teams, fight it out and show their skills. I always wanted to go and attend that.
So you and your friends get your little army men outfits on and try to.
They never let us go. I couldn't get past the gate.
Yeah. Well, it seemed like so after you did that childhood there, and then you attended the University of Colorado at Boulder. Did a bachelor's and got a PhD there, and then you truly wanted to follow Ronald Reagan, and you went to General Electric. You worked at GE, right?
Yeah.
So tell us about that.
Yeah, that was a great experience as well. I think that I've always been on a trajectory. It's just that trajectory keeps shifting, and where I'm headed and what I want to do. Growing up in Idaho Falls, I think my dream was to be a Blue Angels pilot. They were the ones that would come through and fly at the air show, and then it was an astronaut. And then at some point an engineer, and I think from chemical engineer to aerospace engineer, and finally settled on electrical. And GE, at the time that I graduated with my PhD, it was the Corporate Research and Development Center at the time, and it's now the Global Research Center for GE. It was the place to be. It had, they had 1,200 PhDs, on site.
Wow.
The original inventors of so many things. I wanted to be surrounded by bright people, and I knew there'd be a place where I could grow. And I thought
it was probably one of the largest corporations in the world.
One of the largest corporations in the world,
yeah.
And certainly one of the largest research programs in the world, and one of the best known labs in the space. So I was excited. It was my first pick. It's the only interview that I took, and I expected to be there a long time. In fact, when I was in college, one of the graduation requirements was to meet with a career counselor. And I think I told the career counselor my plan. This was the trajectory, and it was, I'm going to go to GE. I'm going to do this research. I'm going to change the world, and eventually I'm going to retire and become a professor. That was my plan. So I went to GE. Got involved, did some exciting things there, worked with amazing people. I remember one of the projects, we were doing energy efficient lighting systems. I was designing some new controllers for fluorescent lamps, and we were looking at how can we improve the lifetime of these systems. And we realized we need to better understand the behavior of these electrodes and how the temperature affects life and how we can start them and control them. And somebody in the room said, well, the individual that invented these, still around. He just retired a few years ago. Why don't we just bring him back? It was just a fun environment. Some of the brightest people around.
So you did your corporate stint with a nice environment, made your way back to University of Colorado, got a teaching position there in electrical engineering. How did you get into electric vehicles? How did that happen?
In the field that I'm in, we call it power electronics, and it's all about how you manage and transfer energy, and it's everywhere. Anything that we do these days requires energy and processing, and in this field there are so many challenges and applications that we can look and consider. And that's something that I've always enjoyed about this field. I mentioned this example at GE when we were working with lighting systems, and so we're looking at, worked with physicists and just understanding things that I'd never thought about before. I worked on satellite systems, on aircraft, and on Navy ships, on computers, and so electric
and how
vehicles.
To manage that power flow within these systems.
That's right.
Yeah.
So every few years, it seems that there's a kind of a new shift and emphasis on where the next big challenge is. Where are we up against a major challenge with either the energy efficiency or the power density, as we call it? How small can we make these things? How do you manage the thermal characteristics of the systems? So in each of those application examples I gave, there was an era where there was significant need and a lot of interest. Electric vehicles, of course, have been around for over 100 years. But there's renewed interest in this past decade as all these things come together. Battery systems, the devices that actually control and manage and process the power, the electric motors as they've advanced. But all these pieces have been coming together to where this is becoming now a feasible system. And so in my area, it was natural that as we looked at the battery management systems for other applications, it was natural that transitioned into electric vehicles. As we look at the electric drive, as now we're looking at electric charging systems, it was a natural progression.
And they're all interrelated.
These are all interrelated. Similar challenges, different application. Now different power levels, perhaps we've looked at in the past. But it's been a natural progression of my prior work leading right into electric vehicles, and now, it seems for the decade to come, this is going to continue to be a very important topic.
Yeah, it's funny. I remember in, what was it, probably 2008? I was working at Rocky Mountain Power, recently joined, and was on a task force with EPRI, the Electric Power Research Institute. We were looking at electric vehicles, and there was going to be this kind of new, and the Volt had just kind of come out, and there's all this kind of new, okay, what are the opportunities? And then we kind of stagnated there a little bit, but Tesla just announced today they delivered 140,000 vehicles this quarter.
Wow.
Which is a record. And so they've really kind of shown, they've kind of taken it now to a whole nother level than where we were 10 years ago when you probably were starting to get into this field. And one thing I want to talk to you about is, so Tesla was about a week ago, they had their big battery day where they talked about really some of these advancements and these developments. And the biggest thing that stood out to me, what they announced was, and I don't know if you've had an opportunity to watch it or listen to it, but one of the things they announced is that they can bring that cost of the battery down. A lot of estimates are today the average battery is about $150 per kilowatt hour. And so they can now bring that down. They announced they can cut that in half. And the $100 being the magic line of where electric vehicles can become cost competitive with internal combustion engines. And so it was interesting where now they've said, okay, we can do it through a combination of materials improvements, materials process, but also a lot of the manufacturing side of it, this kind of industry, how to bring it up to scale. And one of the things that I thought was really interesting was they talked about the tablets. So how the battery, right, how the battery works. You have the electrodes, as you talked about, your anode and your cathode, and then they kind of separate her in between, and then it kind of gets rolled up. But then on the one tab at the end, you have a tab, and that's where the current flows. And so what they did was they eliminated that tab and made it now a direct connection. And one of the biggest benefits they're saying, besides the processing, that's the big cost savings by processing, but it helps manage some of the thermal issues. And I know you have some patents, some battery patents related to some things. So I want to get your thoughts on that, on Tesla's, what they've been announcing and some of these advancements in batteries.
That's an exciting time, there's no question. I mean, you've rattled off a handful of the things that they're looking into. And one thing that, Tesla's always, in my opinion, been, I guess I can just say been good at, but a way that they've been a real leader and a stimulus, a catalyst in the industry, is that they don't shy away from indicating where they're headed and what they think can be accomplished or what they expect has to be done. And I think what that often does, it's a shot in the arm to the industry. It scares everyone around them to say, oh, well, Tesla's going to do this, we better do it. And whether Tesla ever thought they could do it themselves or not, they often put it out there and say, this is what's going to be done. And the whole industry is then...
Kind of the mark in the...
Right. So Tesla's a big company now, and so they can put a lot of might behind this. But every time they make these announcements, what impresses me is, they get not only their might behind it, they get the entire industry behind it, because everybody's scared that they're going to do it and they'll be left out. And so I think this is another example of that. The things they've indicated, these are what many would consider incremental steps, but it's so many. So you do a bunch of incremental steps, you get a real improvement. And each of those steps are not necessarily novel, meaning they're things that many have been talking about in one way or another. The improvements in the manufacturing, the improvements in the contact, the connection, the anode and cathode improvements. The potential benefits working with silicon anodes. All of these things have been in progress, and everybody had these on target. DOE had placed targets for $75 a kilowatt hour or so in a similar time frame, 5 years ago. Yeah. Everybody was hoping for that before, but the slope, there was such a steep drop in the previous decade of prices. And it did stagnate a bit. So we had a shallowing of that slope, and to have Tesla come in and say, look, this can still be done, and we're going to do it. I think it's just a shot for everybody. It's okay, we're all going to do it.
Well, it's also interesting, too, with the whole notion of prototype to production. So I worked at Boston Scientific before I joined the Argument Power, and one of the things I worked on was a coating machine. I actually got a patent on this of developing a chemical coating.
You didn't tell me that.
Yeah, for medical devices. And I remember we built this very simple device that would squirt out a coating with a couple of sponges to just try to coat, a device that you had in there. And I think in just parts, it cost like $50,000 to build this prototype. Mm-hmm. I just remember thinking about that, like the technology in that was nothing. I mean, it was really simple, and it still cost me that much. And then now you can get a car at that level of technology, mass produced at that price, is just kind of an interesting thing. So being able to take it from that prototype to that really production level is an interesting kind of feat.
It really is, and it's going to take significant investment to move some of these final steps forward. To imagine the level of complexity that's involved in the improvements that they're talking about in manufacturing, they're needed to not just squeak out those final pieces of improvements in what we can get from a lithium-type battery. So it's impressive and definitely exciting to see the continued improvement in that space. It's critical to growth of the electric vehicle market.
But one of the things that I'm still kind of torn with or stuck with is the fact that although, right, we're going to get Tesla said they've done it, right? They got below the $100 per kilowatt hour. We're on par. with ICE vehicles. They're now the largest by market share. They're now the largest automaker in the world. Okay, they've done it. But the average vehicle sold today, not electric vehicle, just the average vehicle sold today is $39,000. And so that really still puts into question, as a society, how do we get these types of vehicles? So even if now Tesla can make a car that's competitive with that, it's still really expensive.
Yeah.
And as a society, how do we incorporate that? And it really points out to me the challenges, because transportation is really it's the second largest cost to a household after housing. It's transportation. Families spend more on transportation than they spend on healthcare, food, or education. And I was also stuck personally because a friend of my wife's, who a former colleague she used to work with about a year and a half or so ago, had a situation right around Christmas. She, professional, had a good job, single mother, her car breaks down, and she's really stuck and had to go get payday loans. And it's really interesting how much that it had kind of dominoed effect to where she was almost going to lose her apartment because she couldn't pay her rent, because now she owed this and payday loan. And then she was going to lose her job because she couldn't show up. And so it was one of these things of, it really created a stress and a burden, especially on people that are, most Americans, I think what the average is like, they have $400 of savings or something. And so it's one of those things of how, as a society, we have to find transportation solutions that don't rely on $39,000 a car. Why don't you talk about that, some of the economics and some of your thoughts about that?
I couldn't agree more, and you probably know my viewpoints on this. The cost parity isn't our target. Cost parity with a $39,000 car isn't our target, and really we're talking mostly about cars at these price levels, and this idea of $100 a kilowatt hour, and that being the cost parity point. That's also about light duty sedans. We'll talk about probably medium and heavy duty at some point in this discussion. That's a slightly different story. But even for our cars, what gets us around, we've got to look at new solutions. We need to look at what we often call mobility, but how is it we move people around? And we've got to bring that cost down to make a difference. One of the challenges, you talk about that being an expensive component, but we look at the utilization, is a word I often like to use, in how effective are we both at the use of our cars and any other thing that we're involved in our lives. So vehicles, how many are there in the country? I think as I understand it, last time I looked at the numbers, we have more cars than we have licensed drivers in the country.
I think the average, there's like 2.3 cars per person.
I think it's somewhere in that ballpark.
Yeah. Just happened to have looked it up, right?
And so I don't remember the exact number, but to make math easy, let's say it's 100 million. It's probably closer to 300.
Yeah,
but let's say it's 1 to 200 million, and let's say we're only a $10,000 car. We're already in the trillions of dollars. And if we're actually $40,000 average, we're in the high trillions of dollars. And our vehicles are, they spend 95% of the time parked. And so trillions of dollars of investment in the country at 5% utilization. It's a major investment. That's a high cost. So as we look to the future, we really need to be looking beyond cost parity and more than even just cost parity, even functional parity. We need a new solution. And as we look to the future, we are trying to understand how is it we can bring overall cost of moving people and goods not just down, but significantly down. And we think that's possible.
Yeah, well, especially globally too, because it's one thing where it's, the United States, well, maybe pre-COVID we could afford to buy $39,000 cars, but the rest of the world can't. All right, you just can't. And so we really have to come up with different solutions, especially with transportation being being the largest source, at least in the United States, the largest source of greenhouse gas emissions. We have to find new solutions to address that. And if you look at it globally as well, that just finding a price comparable solution that's not enough.
It's not enough. And if it's if it were price comparable and environmentally comparable, neither of those are anywhere close to enough. So we need costs down, and not just down a little. We need them down by a large number, a large factor. And the economic or the environmental impact has got to come way down. Another thing that we talk quite a bit about is the equity of all of this. And that's partly what we're getting at here with cost as well, and partly with the example that you gave. But we need the new solutions to be accessible to everyone. And that includes low-cost movement of people and goods.
Yeah, it's interesting where there's definitely different consumer preferences, like in the United States, obviously, with the preference of SUVs and trucks, and we can have a whole nother debate why that is. But it is
and whether that can change.
Yeah, well, I know you talk to my son, and generationally, there's definitely a different view on that. I know when I was growing up at a high school, right, you viewed your vehicle as an extension of your personality for some, but I think with kind of the next generation is not so much. I think maybe their phone is more of an extension than the actual vehicle. But one of the things that's interesting is this notion of what is the type of battery we need for a battery electric vehicle. What is the kind of battery we need? Right, if you're just a daily commuter going to and from work, the average is about 30 miles a day. If you have the ability to charge at home or the ability to charge at work, you really don't need that big of a battery. I know in that 150 mile range is probably the sufficient, even though Elon Musk is saying 300 miles is that's it. He's kind of, your comment earlier about setting the mark, he's basically saying, all right, 300 miles is it. Anything above that is basically a luxury vehicle that, like the Lucid and all these other, the Model S Plaid, all these other vehicles which are having 500 mile ranges. But it looks like 300 miles is what they're targeting, which is interesting. Do you think that, I can see it from a day-to-day, there's a convenience factor in there, but what are your thoughts on that as this kind of optimal battery size?
Well, the optimal battery size is a complicated question. And another aspect that I think complicates that question is it the optimal battery size, for any given user group, and you just walk through a handful, is the optimal battery size for 5 years ago or 10 years ago, for today, or for even 10 or 20 years from now or beyond? Because the likelihood of how we operate and use our vehicles, you gave the example of your son as one, is likely to be changing, and is probably going to change sooner than we think. The statistics that you've just mentioned have been known for a while. So the Nissan Leaf was marketed specifically to that, knowing that 60, 70 mile range was twice what over 80% of all drive cycles needed. That should have just dominated the market, but it didn't. And why not? Well, partly availability and informative, there are all kinds of societal, social, economical
people want to be
drivers.
able to have their vehicle for that 5% event.
A big part of it's that 5% event, and that's how we make our decisions. And they're real, because for a variety of reasons on how that market was set up. So, as we think about what's that optimal sizing for the battery, I think you're right on for the commuter vehicle. Trouble for the U.S. has been that that's only the scenario where it's probably your third vehicle. So if you're going to buy a car that's just your commuter vehicle, it's probably not the family vehicle. It's probably not the long haul vacation vehicle, so it's your third vehicle. And now we're talking about a specific group of homes, those that have the 3-car garage and the room and the space for 3. It's not where we need to end up. What's next? How much is enough? I've got the Chevy Bolt. I guess I'm one upgraded up from you. So I have close to 260 mile range, and that it's working great. I love it. I drove it down here. I come from Logan down to Salt Lake and back. Close to a 200 mile trip, and I have no concerns, no trouble managing that. I charge at home. I charge off the solar panel at the lab. So that works great. But the times that we have taken trips, it's not enough. It's a challenge. We average less than 50 miles an hour, probably closer to 45 on a longer trip. when you factor in the, selecting the right
Stops.
locations and charging and stops and getting going again. If we had, at least that additional 50 miles, 300 would be nice. 350 would be great.
Yeah.
Most of us are comfortable because, the gasoline vehicles, we have 450, 400 plus mile range. The other trouble is we think about different scenarios. I mentioned different user groups. Here what I mean is, there's you and I driving home and work and sometimes on a trip with our family. But what about others? We've worked on projects in the past where we've looked at ride-hailing services, the TNCs or taxis. We look at fleet-operated vehicles. These are going to be running a good portion of the day, and they don't stop.
Yeah. No, it's interesting that you bring that up, where we have a lot of the light-duty vehicles, which are so consumer-driven,
right?
With preferences. Joe needs his big F-150 so he can go take his boat out, and so there becomes so much of that preference thing, and so cost ends up is only one aspect. It's not the major, in some cases, like in Joe's case, it's not the major aspect. It's just it's one aspect of it. But as you're talking about fleets, and we start talking about training, where now we start getting into that, costs become a much more deciding factor when you're looking at vehicles and you're making those decisions. Why don't you talk a little bit about that?
That's right, cost and what we might call quality of service, but meeting the requirements of that fleet through the day. I mean, you look at the economic model of whichever business is operating. Now this is a more data-driven process. The process that you just described for Joe and probably for the reservations we each have for our Rivians and others like this, that's a bit more emotional, as well as driven by a subset of our needs. But the fleets, they're looking at their daily needs, and cost is definitely a significant factor. And I think cost probably comes right after meeting the quality of service or the basic requirements. So we have to be able to meet the requirements of that fleet. And as we look at fleets today, we might also consider where are those fleets headed tomorrow, as we have more connected and potentially semi-autonomous and leading into autonomous fleets. These fleets may be operating 10, 15, even 20 hours a day. Yeah. And their charging needs are going to be quite different than the needs of our vehicles.
It's also interesting. One thing that gets stuck with me is when you make a financial purchase and you get this bigger battery, and you deploy that capital to get that bigger battery, so you have this range, this convenience. But now, as a business and a fleet operator, you're now making that investment, but you're not utilizing that investment. So now you actually have this capital that's kind of sunk and lost into the vehicle because you really don't need that much of a range. And so why don't you talk about some of the solutions of that, where you can not have to use such a big battery, but still meet some of the needs of fleet operators and fleet vehicles?
Yeah. Certainly the primary requirement here is meet the need, as you've just highlighted. And so what are the opportunities to meet those needs? First, all fleets are looking carefully at their operations. What are the routes that the vehicles have to run? Today, it's typical that they would desire that all vehicles can run all routes in whatever the mode of the fleet is, whether it was a transit agency, a taxi fleet, emergency response personnel, or delivery, which are all good examples of fleets we would have in the cities. So in each of these scenarios, traditionally, we like to see, when we're scheduling and planning operations of these fleets, we like to simplify the operations, which means we don't have to carefully consider which vehicles are in, which vehicles are out, where are they running. So they prefer these vehicles run all routes. But one of the first things you do is analyze those routes and consider, okay, if, financially as we look at this, if it turns out 80% of our routes are less than 100 miles, then let's look at vehicles that will be cost effective for that routing. If a certain percentage are going to require 150 or 200 miles in a day, then we start looking at the scenarios for this. Additionally, we look at the operations throughout the day and what's happening through the evening. And if we're looking now to shift to an electric vehicle and now optimize what are the charging options and what's the size of the battery that's going to be ideal for that fleet, now we look at the scenarios. If it's going to run 8 hours a day, 10 or 15 hours a day for however many miles that goes, We consider, okay, here's the size of the battery that's required if it's going to run continually throughout that day, and then we do what would be called a depot charge, or a charge overnight. And we look at the economics of that option. Another opportunity that many are looking at is, well, what if we do en route charging? Or in other words, can we charge during the day even while we're in operations? Either with delivery trucks, could be when we're stopping for pickup and drop off, could be along the routes as well. So that's a scenario that now you look at and say, okay, well, where's the infrastructure for this type of charging? Do we have to own that ourselves if we're Walmart or an Amazon, UPS, or FedEx, or are there public charging options? As you look at the infrastructure for that charging, now you can say, okay, given the routes, given the timing, perhaps I could have half that battery size or even a quarter of that battery size if I can now manage the charging partially through the day and partially through the night. These are examples of scenarios that are being considered. And something that you and I are both familiar with is now kind of managing that charge through the day.
Yeah, so of the ability you mentioned the infrastructure and the ability to charge these vehicles. Right now, the most common way to charge is through a conductive plug. You just get this plug and you manually put it in there, or even in some buses, I guess they have an overhead where it comes in and it slides in, but it's touching. There's a conductive connection there. You're actually one of the world's leading experts on inductive charging. So why don't you tell us about inductive charging and what some of those differences are?
Well, you're being liberal on so you know where my passion is, and in the programs that I've led and have been involved with have really looked at this possibility of cutting the cord, of breaking that contact-based scenario. And this includes colleagues and collaborators, around the world looking at this opportunity. And what are we after? A big part of the challenge with electric vehicles and a contact, plug-in based solution is the flexibility on kind of when are you plugged in and how does that impact both your charging opportunities and the size of the battery requirements. So this idea of cutting the cord and actually going wireless, contactless in how we charge, it's more than even just a convenience. It's so true now when I go to my garage, if I had a wireless charger, I no longer have to remember to plug it in. If I have a fleet of vehicles at the airport that I'm managing and operating, I no longer depend on all the linemen and operators, personnel to plug in. These are conveniences and can make a real difference.
And I'll tell you, where I work, we have some pool vehicles, and there's always that guy who takes the pool vehicle, the electric vehicle, for lunch or goes and does whatever and doesn't plug it back in.
They don't plug it in.
They don't know how.
Now you show up the next opportunity, and then it's not. So even that convenience factor is a significant one. So there are scenarios where that really makes a difference. But the difference that we're really after is on a much larger scale. So now if we go beyond the few percent adoption of electric vehicles, for example, in our country, and now start looking, well, what if we had 10%, 20%, 30, or maybe even 50% and more? How do we operate, manage, and coordinate all of these vehicles? How much battery is it going to take? Where are the charging opportunities? Now we're going well beyond really the opportunity of charging at home and charging at work, because we're looking at a much bigger class. We're looking at those that don't have private garages and private parking. We're looking at fleets that need operations through the day.
And they need to be charged during the day.
And they need to be charged throughout the day. And so now how does this operate? Another question that we haven't really hit yet is, what are the implications on the electric utility? And how do we manage that charge and coordination? So these all come together, the implications on the utility, the charging rates that we're considering, and the opportunities on kind of how, when, and where do you plug in and charge. If we look at this chance to cut the cord and perhaps now deploy wireless charging solutions, not at off locations where you drive off to and you connect and you charge like you might think with the gas station model, but instead, if we can actually make this what we often term as a seamless experience for the users, where we actually bring the charging to where the vehicles normally park, where they normally operate. Can you imagine a scenario where the vehicle simply is always charged? Kind of like your cell phone. We don't really think much more about, are we in range or not? Are we going to get a signal? Most places you just assume, of course you have a signal, you're going to call someone. And unless you're in the far out regions, you might wonder. But in a city, when you're walking around, you just expect your cell phone to work. What if your electric vehicle were just charged and it always worked? What would that do to adoption and the perception of users on the acceptability of that vehicle? And then now even beyond that, your question was on the battery size. How would it potentially impact the battery size? Well, if we could charge that battery, essentially at will throughout the day, it's possible in some scenarios you could have almost no battery. In a more realistic scenario, you could have the size battery that we talked about, 30 miles, 50 miles, 70-mile range. Now, if your vehicle had a battery size of this level, we talked about the $100 a kilowatt hour being that break-even point. That was assuming you were competing with the 400 or 500-mile range, battery. But if we actually could live with a 50, 60, 70, maybe 100-mile range battery on the vehicle, we're at cost parity today. That solution would mean we're already there. Now we decrease battery cost by another factor of 2, and we find solutions that bring electricity costs down. Now you're looking at a purchase price of a vehicle that's significantly lower than the existing cost, and operating costs that are a fraction of what the fuel costs are today.
Yeah, you talked about some of the impacts on the grid. When you talk about a single vehicle, obviously, one passenger vehicle isn't going to have an impact. But when you start talking about some of these bigger vehicles, and not passenger vehicles or light duty, but really more medium and heavy duty, especially as we've talked about this before in some of the early episodes, but with COVID, we've had this shift now happen with the way goods are moved. People are no longer going to the store to get their goods. The goods are coming to them. Prior to COVID, it was 2% of groceries were online purchases and delivered. Today, it's 20%. So we've seen, and these are probably changes that are going to be permanent. And so we're going to have a kind of a different shift, and we're going to have these type of different vehicles moving goods around differently that are more medium and heavy duty. And so why don't you talk about that and some of those impacts? Yeah,
the impacts of having more medium duty, heavy duty vehicles operating. What would be the impacts to the grid? It's interesting, just looking at the size of these industries that we're talking about. So now as we bring in this electric utility, and clearly this is a big part of electrification in vehicles. If we look at the electric utility industry and the transportation industry, we're talking about two of the largest industries in the nation. And how much money is involved here, how many jobs are involved. On the vehicle side of this, last time I looked at the numbers, if you add up diesel and gasoline, the business is somewhere in the ballpark of $450 billion a year in fuel, just moving our vehicles around, and that's moving people and moving goods. Well, the electric utility industry is about the same size, and so it's not dollar for dollar when we shift to electric. There are a lot of complicating factors here, but just roughly speaking, if we were to shift to all electric, we're talking about doubling the electric utility in the U.S. This is a big...
Which our shareholder would
which your shareholders may appreciate. But when you think about the challenge ahead to do so, we look at what happens if there's if the summer's a few degrees warmer and there's a bit more air conditioning on some hot days and just the challenge of managing that load. Well, what if we doubled the entire load? That's a significant change. And in these individual vehicles that's talking about us at a large scale. So this has to be considered carefully. And as we look at how to deploy that type of infrastructure, and we also consider what are the costs of that level of deployment, this requires some strategic thinking in how we do so. But we bring it down to a smaller scale. How does it impact a local region? What's the requirement for medium duty, heavy duty truck? And if these were to increase in a region for deliveries as you suggested, well, what are the charging requirements? It depends on the solution. In kind of the futuristic scenario that I presented, well, what if we cut the cord and the majority of charging for those vehicles could be delivered on the go as they're operating? The instantaneous the real-time requirements perhaps are manageable. They're not as high. But if we instead have to stop and do a very fast charge for those vehicles to keep them running, once an hour, once every 4 hours, for a heavy-duty vehicle, we're probably we're looking at megawatt-hour batteries for a long-range heavy-duty vehicle. You want to charge that megawatt-hour vehicle in an hour, it's a megawatt. Yeah. But you don't want to charge it in an hour. You want to charge it in 15 minutes or 10 minutes, half an hour at most. So each vehicle, we're talking about multiple megawatts. And so fleets in the city of Salt Lake, just driving in here, I don't know how many heavy-duty trucks that I passed, but right in this region, you can imagine a single truck stop, how many trucks do you see? Each of them would be multiple megawatts. And so that's something that has to be considered, and definitely a potential impact on the grid.
Yeah. No, I know that thought of it has the megawatt charger creates, right, two types of initial reactions. Like one's like, oh, well, that's great, but then it's
Hey,
another
megawatt.
yeah. But then also at the same time is and it kind of goes back to that notion of, right, just like we don't want to build or buy a battery that's not being efficient, not being utilized. We don't want to build infrastructure equipment that's also not being efficient and utilized. So you gotta have to balance it. I think from a utility standpoint, as long as it is being used efficiently, we'll be able to deliver it. We'll find a way to do it because that's what we do, and we can, there'll be an initial upfront cost, but if it is utilized, then you're right, it shouldn't be a problem. We'll be able to cover that. But it's when it's not efficient, where it's just kind of on demand, spotty, that's where we could start creating problems, or if you're already adding to peaks and that sort of thing. But we'll get into that. We'll get into that in a minute. Were you going to say something?
Probably what you want to get at in a minute. But yes, I have many thoughts on those points.
Yeah. We'll do a deeper dive in that in a second. But I did want to talk about first, before we do that deeper dive on how to you create efficient infrastructure. You just got awarded a $50 million National Science Foundation Award. Congratulations, by the way. Called the Aspire Center. Tell us about the Aspire Center.
Oh, absolutely. So we've been talking about some of the challenges in front of us for advancing electrification and advancing electric vehicles, and what it could mean, for the economy, what it could mean for the environment. And it's been growing. The need here and the opportunity has been, in many ways, as I would pitch it, the stars have been aligning for the opportunity. So the Aspire Research Center, it's a National Science Foundation funded program, and it's intended for exactly these types of challenges. Those where an engineering approach, an engineered solution, can meet a significant societal need and have global impact. That's the type of thing that NSF ERCs or engineering research centers are after. And we just think this is the perfect fit for an NSF ERC of this scale. They're intended to be catalysts for significant change, to bring together partners from across industries and disciplines to make this happen. So what is Aspire? So Aspire is, we're a collaborative team of multiple universities, of national laboratories, of industry members, industry partners, government agencies, nonprofits, with this common vision of making the world a better place, and doing so through advancing widespread electrification of vehicles across the transportation space. We have a vision for a future with, improved air quality, with, economic stimulus through low-cost transportation that's accessible to all. And to accomplish this, we believe this is going to require, what we call a holistic approach, but an all-the-above approach. We've talked about various, possibilities and solutions and opportunities. Well, with the Aspire Center, what we're doing is we're bringing together experts from multiple disciplines across engineering. We're bringing together business experts and those that understand the techno-economics and socioeconomics. We're bringing, even in policy and considerations of how does society need to rethink this and consider change to make it all happen. So we're bringing all these teams together with industry and with government to say, okay, what's the chart? The nation and the world's in a similar place. We're estimating trillions of dollars required in investment for the electric utilities and for our roads, both aging over the past 50 to 100 years. And as we look at investments of that scale, and we look at this opportunity for environmental and economic impact of electric vehicles, we think it's a perfect marriage to now kind of rethink major investment in the coming decade. So the role of Aspire is to chart that path. We consider ourselves at least we would like to become the trusted, the trusted guide, the Yoda of kind of the future here. I'm coining that term from some colleagues here in our program. And so that's what Aspire is all about. You're probably wondering if I'll ever define it. It's an acronym that pulls in these pieces.
Yeah, no.
So advancing sustainability through powered infrastructure.
Yeah,
so that's what we're all about. It's all about the charging systems and infrastructure, to break down the barriers to adopting electric vehicles.
Yeah, because that becomes a lot of the forgotten aspect, especially a lot of focuses on electric vehicles has historically been on batteries. How do you solve how do you crack the battery nut? But then we've kind of forgotten that there's that infrastructure side as well, that unless you can manage that seamlessly, you're not going to be able to deliver it.
And if you don't do these together, you're missing a big opportunity. And that kind of gets back to this idea of, are we going after cost parity, and are we going after, are we considering the environmental, parity? Or do we really want to look at these holistically or together?
Yeah.
And that's what we think is critical. So not only are we looking to solve the infrastructure challenge, but as we look at potential solutions, and our approach is a combination of new innovative ideas on charging systems and implications on infrastructure, and what we call co-optimizing, but essentially merging and coordinating the traffic systems, our vehicles and routes and operations, and the electric utility and its loading and demand. And can we bring all of this together, maximize utilization, the battery on the car, the miles that we drive and how and where we drive, and the electric utility and how the infrastructure is built out. Can we maximize utilization on all of those? And with that, we truly believe that we can bring cost of transportation down by more than a factor of 2. The entire cost, total cost of operating.
Yeah, that's great. And as we're looking at those approaches, we're actually collaborating. We got 2 Department of Energy awards in partnership with the Aspire Center. One is the West Smart at Scale, which is a $6.6 million award to help create a regional EV ecosystem to really address the multiple issues of underserved regions, of destination charging, some of the trucking and some of these other issues, and TNCs, or Transportation Network Company, the Ubers and Lyfts. And then we also got another award, eMosaic, in partnership with our partner at ABB. We're looking at utility managed smart charging. We have these two awards. One of the common technologies that we're developing, or projects that we're developing, is the Intermodal Hub project. And with Rocky Mountain Power, the Aspire Center, and the Utah Transit Authority. So tell us about that, because it links into both of those DOE awards, but it really showcases what Aspire is all about.
Really is. At a small scale, this was a great starting point. And I remember it was one of the early discussions you and I had. I think it was one of the light bulbs that you had one evening and calling me up, probably in the middle of the night, if I remember right. But say, hey, I got an idea. We should
please take my call if I call you at 3 in the morning.
But the idea is, let's rethink this. The baseline thinking for infrastructure and electric vehicles, A, was that we're going to put enough battery on the vehicle to make it equivalent to what people expect from gasoline, and B, that we're going to turn our gas stations essentially into substations of power, charging stations, all major charging stations. And these were done in each case without kind of thinking, how is the location right? Is the utilization right? How do these really merge? And so the suggestion that was considered here, and that's what the Intermodal Hub project has become, is to say, well, let's kind of rethink this and say, okay, at least for the rollout, for this early deployment and transition, as we grow the number of electric vehicles on the road and opportunity, let's rethink this and say, okay, instead of saying, okay, we're going to add electric vehicles in demand and assume that they can charge just about anywhere, let's start by saying, where is it we have excess capability? Where do we have flexibility to add demand on a site? And so the Intermodal Hub was a good example. It's the central station for the Utah Transit Authority here in downtown Salt Lake. And this is an area where the TRAX line was brought in, and we have an electric train, and it has high demand. And this was a very expensive infrastructure build for that one mode of transit. It has over 10 megawatt charge or pole, electric pole, power pole off of the grid. But that only occurs once every 15 minutes, 30 minutes, and only when the trains are operating. But the UTA, the Transit Authority, has to pay for that infrastructure essentially, and they pay for it through the connection fee, and they pay for it through the demand charge. But the utilization is quite poor because it's one big spike and then a big gap and then another big spike. And so back to this point of, well, why don't we start there? Here, look, we have excess infrastructure, poorly utilized. Are there electric needs? And we say, okay, well, at the central station, we have multiple modes of transit. We have a lot of traffic. It's central to Salt Lake. It's close to the interstate. Look at this. There could be significant additional needs in transportation to leverage this one site. So the intermodal hub concept is, well, let's take those peaks and see if we can fill in the valleys with similar levels. And if we can now level out the demand throughout the day, we can significantly improve the utilization of that infrastructure. And that makes the electricity cheaper for everyone. Infrastructure costs stay the same. We're delivering far more energy. So now the price per kilowatt hour or price per kilowatt is significantly going down. So with the Intermodal Hub project, we're combining multiple modes of transit. So we take the electric train and its demand requirements, combine it now with electric buses, and that's where UTA has really stepped up. We were expecting 2 to 4 buses on the project, and now I think they have an order out for 50 to 100 buses and building a whole new depot, and we really see this rolling out at a sizable scale. And so that level of thinking has allowed us to say, okay, how many sites are there like this? Where if we had managed charging, if we could now coordinate the scheduling and management of the traffic, the charging needs of the vehicles, look at en route charging, look at overnight depot charging, and if these could be controlled and managed, and if we can now combine not only the train but the bus, what if we could attract public charging, the TNCs, the taxis, what if we could also bring in local delivery vehicles, and they're coming by this area, it's centrally located. So now we start thinking, well, perhaps we send pricing signals, we do demand response, we can now start changing the behavior of the users, and we start filling in these gaps. This is that integrated systems of systems approach that we're talking about. It's combining user behavior, traffic operations, vehicles and modes of transit, ultimately all tying into charging needs. Multiple charging technologies. In this case, at the hub, we're doing a high-powered overhead charger. We're doing a plug-in charger overnight, and then now we can start looking at future opportunities for wireless charging and other solutions. But we combine all of that with management of the charging on the grid, and suddenly we're looking at cost per mile for vehicles at a fraction, small fraction of what gasoline costs are.
Yeah, well, and I know the Transit Authority, they're looking to expand a lot of their electric buses, a lot of because of the work you're doing, that they're counting on you to to deliver these cost savings. A lot of expectations on there, but.
And we see opportunities to expand it, right?
Yeah,
so this was a pilot.
The technology's not just limited to transit. It can be used in other.
How many locations are there where there's poor utilization on the utility, and can we center our thinking around them? Grow adoption of electric vehicles in this space, and then as we exceed the infrastructure in those sites, we can start spilling over. And now that's where it makes sense. Now it's cost effective to upgrade the electric utility in these regions because the demand's there. We built up the demand by doing this strategically, cost effectively. And we've looked at this, we said, look, there's sites like this all the way up into I-15 in Utah as a first example.
Yeah, and this year in 2020, the Utah legislature passed House Bill 396, the Electric Vehicle Charging Infrastructure Amendments, which really sets up the public policy to allow Rocky Mountain Power, to allow the local, the large utility to make investments in electric vehicle charging infrastructure. And so really it's kind of a game changer in that sense. And I think if you couple the research that you've been doing and now the expertise that you're bringing to the state, we also have some of these Department of Energy grants on that as well. Now we have some resources to really go out there to start deploying some of this infrastructure. Utah really is positioned to be a leader. And if you think about outside of really California's all on their, they're in their own, but really outside their per capita locally, this is where one of the most, per capita, most work being done in electric transportation. So with this $50 million program, one of the things that we're going to be looking at doing is how do we expand the infrastructure through the state so we can make sure the whole state's covered, kind of get some of those consumer preferences so you can on that, that camping trip to southern Utah that you think you do more than you actually really do, more often than you actually really do. That way you can go down there and go camping. You can really go anywhere in the state, so we'll get that range addressed. But we're also wanting to focus in on high volume users, the users that you were just talking about, because that's really where the economics is going to start changing. And so where we can really focus on these fleets, on these heavy duty, medium and heavy duty. The legislation also calls for investments in the inland port and the point of the mountain. So can we electrify the inland port? And if the answer is yes, how do we do it? How do you see that?
Well, the answer is yes, absolutely. And for the programs and the investment that you've just highlighted, it's impressive. It's couldn't be more excited to be here in Utah now at this time where there's really an opportunity to be a showcase for the future. And that future, we believe, really needs to be an all-the-above approach, the terminology I used earlier. And I think that's appropriate for the inland port as well. So combining the efforts, as we look at what Aspire can bring, headquartered right here out of the state of Utah and partnered across the nation and even internationally. Now this $50 million coming in from the investments with Rocky Mountain Power and the opportunity that brings, and the state is behind this. Inland port now being, kind of a blue, it's an open sheet where we can now lay this blueprint of how should medium heavy duty vehicle electrification occur. How does this roll out in an area where Salt Lake's a great example where it's an urban area, and yet it has the combination of suburbia surrounding it and rural areas further out. We can showcase so much here in the state, and with the inland port being a new facility and opportunity, we can experiment at relatively low cost, compared to attempting this at the Port of LA, or in one of the highest density ports in the nation.
Well, and a lot of things too. The Utah inland port is really designed to relieve some of that congestion at the Port of LA, and it also gives opportunities locally too. But
showing a path what else can roll out. So now how should this be done? I mentioned an all the above approach. We should go in and look carefully. Let's look at the various customers, site owners and operators are going to be there on site. The FedExes and UPSs and the Amazons and others that may be there. Look at their routing and understand the fleets in operation, and now look at a combination of charging solutions, projections and informative data that we can provide and show, okay, here the size of batteries would be appropriate, here's the type of range that you're going to need on these various vehicles. And then let's look at this combination of charging solutions. I'm confident that there would be an appropriate application here for a combination of each of the things that we've talked about. Certainly the depot type charging overnight for many of these fleets. I think that's going to be combined with opportunity charging, and frankly, I think the likely best scenario for that is going to be to cut that cord. Have that opportunity where some of these vehicles can, as they're running their deliveries and their routes throughout the day, they can be topping off at each of the locations through a wireless charger. I think that's part of this all the above solution. And then as we chart this out, starting this inland port with probably 80% of the routes coming out of there are likely to be local. So starting with these localized vehicles, with their depot charging and their en-route charging at source and destination. And then now expanding this to consider, okay, what if we start with that inland port and consider the longer routes? Now let's go from Salt Lake down to Provo. Let's go Salt Lake all the way up to Ogden and up into Brigham City. Now as we start looking at this expanded region, we might start considering, well let's tackle more than just the inland port requirements. Let's look at the broader vehicle requirements. And now we might even start looking at I-15 and say, okay, let's even electrify portions of I-15. And now have a combination of requirements that would bring down the battery needs, bring down the vehicle cost, and really achieve a solution that would be economical across the board.
Yeah, so with the inland port being one of those really large developments, the other big development, so the inland port being focused more on kind of a heavy duty manufacturing type of development. We also have the point of the mountain now called the Point, which is really more of a high tech. It's the silicon slopes replacing obviously the prison, but prime real estate right in between the Utah and Salt Lake County, and really there really is a high tech. There's so many high tech companies out there. They view this as, the state views this as this prime location to attract. So some of the ideas that have been coming out is, can we create an autonomous vehicle zone there to let some of these vehicles come in? And can we even have flying taxis and drones in there? So what are your thoughts on that?
Well, it's an exciting future, and some of these sound crazy. Even the concepts we were describing before of electric vehicles at volume might have been seen as crazy some time ago. The idea of cutting the cord and wirelessly charging a vehicle would have been considered crazy before today. And then now this idea of the drones with flying taxis and everything else combining with autonomous vehicles. Now that might still feel out there, but it may be closer than we think, especially for new developments and controlled environments.
It's a lot closer than people realize.
I think it's likely a lot closer than we realize. And boy, the marriage with electrification is just natural. And as you look at autonomous vehicles and the ability to operate and run the vehicles throughout the day, and to forget about how, when, and where that you charge those vehicles. So combining electrification and automation in the way that we control and operate the charging system, with autonomy in the vehicle operation, it's just a natural fit. And now looking at this holistic architecture, the combination of infrastructure needed and looking to share that infrastructure across these heavy-duty vehicles coming out of the inland port up and down I-15 and perhaps even delivering into these regions. These autonomous vehicles going within new development like the Point and operating within that region. And then now the delivery vehicles that may have the drones that come off the delivery vehicle. The combination, all electric, combining now charging solutions and systems. It's an exciting future, but I think it's one that is earlier than sooner than we think, as we just mentioned. But boy, by strategically thinking of how do we coordinate and manage the development of that infrastructure and coordinate the operations of these various modes of transit and fleets and vehicle types. Can give us high utilization of that infrastructure, low cost for everyone, and reduced emissions. It's an exciting time. Electric aircraft, the air taxi. One of our partners right out of Aspire, Electric Power Systems, is right dead set in that space out of Logan, and that too, amazingly enough, is sooner than we think.
Yeah, well, and it really is exciting, and it's exciting that the Aspire Center is front and center on that, and it's going to be a key kind of cog in making that all happen, and it is exciting. And
headquartered right here out of the state of Utah. I've got to put my tip of the hat and note to the state for future thinking. What brought me here was the U-Star program. Out of when I was at the University of Colorado, they brought me here to think about transportation as a future in an electrified future. And now 10 years essentially after that, we're looking at this Aspire grant that can really make a difference in showcasing the state. And again, the state was a key player, if not the key player in decision points for the ERC by investing in Aspire. So, the state's been forward thinking, both from the state, the state government, UDOT has been well known as a forward thinker in the space. UTA has been involved with us. Rocky Mountain Power has been a key partner. Just excited to be here and see this happening, right in our backyard. Yeah.
Last question, Cybertruck, love it or hate it?
I'm not going to comment on that. I couldn't be more excited about any electrification in the transportation space. I think these are all moving the needle forward. I do have a down payment on the Rivian, but anyway.
I do too, but also I did put my name into the Cybertruck. The Cybertruck is one of those things that just kind of grows on me.
It grows on me too. When I first saw it, I thought, wow, where's this headed? But
I made sure I measured my garage to make sure it could fit, and I'm so glad they announced they shrunk it a little bit.
So it actually fits. I did the same thing. I was measuring the garage as well.
And it's funny, because I do want to be like Joe and get the truck, and so I think the Cybertruck can really be my ability to kind of keep up with him. So
the funny thing here is, I had a truck 20 years ago, but for many years, I haven't had a need of a truck, and we've had bottom line is that hasn't been a need of mine. But now that electric trucks are a reality coming up, suddenly I need a truck.
I know, if you can,
There's no question I'm
if you
getting
can,
one.
if you can drive a tank at 0 to 60 in under 3 seconds.
You kidding me? Of course I'm going to do that.
Yeah, no, so, I think we're out of time. Professor Zane, thank you so much for joining us and giving and sharing us with your thoughts and all the exciting work that's being done up at the university and with all of your partners as well. It really is, it's crazy right now with all of the craziness and politics and pandemics and all of that of the economy out of whack.
What a time
all
we're
of
in.
that stuff, I have to confess that electric transportation is the one thing that kind of keeps me hopeful on society, that this is something that actually there's a solution, a path to go forward.
That's
and
right.
And you're helping make that path, so thank you. Thank you. And
Really appreciate the invitation. What a pleasure it's been to have this conversation. How exciting, to be here in this time where we can actually make a difference, where we can really see a brighter future through the work that we're doing, and to have it be a nonpartisan issue. This is an exciting time.
yeah. Well, I think that's it. And Chris, Joe, do you guys have anything to add?
I think you got all of my questions out. Thank you.
Well, again, thanks. Well, thank you everybody for joining us. Again, this is Live Electric Now. My name is James Campbell, and thank you for joining us. And thank you to Project Open and the Give Group for hosting us. And here's to National Drive Electric Week. And goodbye. Music always gets me in the mood.
We have no idea when we're done, huh?
Yeah.
Anyway, a lot of exciting things happening.